Welcome to Concepts in Chemistry. In this talk, we will discuss how to separate mixtures. To start, let's review this diagram. Now, if you recall, this was the same diagram we used to classify matter by composition. So again, let's look at this diagram. Now, as you can see, matter can exist as pure substance and also as mixtures. But in nature, most things always exist as mixtures. Only few things exist in pure form. So, mixtures are usually separated to get pure chemicals. So how do chemists do this? Now, chemists usually do this by taking advantage of the physical and chemical properties of these chemicals. So let's look at some of the techniques they use. So generally, mixtures can be separated by taking advantage of their physical and chemical properties. Some techniques that take advantage of physical and chemical properties include distillation. Okay, so distillation takes advantage of differences in boiling points. So if you have a mixture of liquids, these liquids, of course, would have different boiling points. So once you heat them up in the distillation apparatus, the chemical with the lowest boiling point will boil off first, followed by the next, and next, until all the chemicals are separated. Okay, so distillation is a common technique for separating mixtures. Now, crystallization also is another technique for separating mixtures. Now, crystallization usually involves differences in solubility. Okay, so differences in how chemicals dissolve in a solvent. Okay, so now filtration is also another technique. Filtration takes advantage of differences in particle size. Okay, so once you have a mixture that consists of different chemicals with different particle size, you can always filter them. So you just have to make sure you pick the right filter paper with the right pore size to be able to filter out what you want. Okay. And the next technique is chromatography. Chromatography also takes advantage of differences in solubility. Okay. Now, as you study chemistry further, you would, of course, practice some of these techniques in the chemistry lab or even in your research. Okay. So now let's look at how to apply these techniques to separate a mixture. So here I have a question for you. How would you separate a mixture of sand, salt, iron filings, and water? Now, note that the iron filings, sand, and salt have identical particle size. So what this means is that they all have the same particle size. So let's say if you were to filter them using a filter paper, you basically filter all of them because they all have the same particle size. Okay, so so that's what it means. So now, how are we going to separate this mixture? So our mixture is sand, salt, iron filings, and water. So what should we do? Let me give you some time to think about it. Now, as you think, try to write your answer down. That is, try to write the order in which you would separate them and what techniques you would use. Okay, this is what I would do. Now, the mixture consists of sand, salt, iron filings, and water. So since I have water in there, that means that the salt is going to dissolve in water. Okay, so the salt will dissolve in water. Okay, but the water, of course, wouldn't dissolve the iron filings and the sand. Okay, so clearly once the salt dissolves in water, I'm left with just the sand and then the ion filings. Okay. So what should I do? So basically what I would do is, since the salt dissolves in water, but the sand and the ion filings are still in there, that is in particle form, what I'll do is I'll try to filter them out. So I'll get a filter paper and try to filter out the sand and the ion filings. So once I filter out the sand and the ion filings, then I'll then proceed to use a magnet. To use the magnet to separate the ion filings from the sand. Since magnet attracts ion filings, that is the easiest way to get the ion filings out. Okay, so once I use a magnet, I get out the ion filings, and now the ion filings are out of the sand. So my sand and ion filings are separated. So now I'll move on to the salt and water. Now the salt and water, of course, forms a solution. Okay, so the salt is dissolved in the water. So there's no way I can filter out the salt. So the only way I can separate the salt solution is to evaporate. Okay, so I evaporate. Now if I want to collect my water, then maybe I can do a distillation, whereby the water evaporate and then condense, and I'll collect my water. Okay, yeah, but of course I evaporate the water, and then the water would all evaporate and leave out the salt. Okay, and the salt will crystallize out. Okay, so that is how I would separate this mixture. Okay. So that is it.